Hello, I welcome you in today's video where we'll be solving the question from GATE Life Sciences. So the topic which I have chosen for today is protein expression, regulation and activity. So I have chosen today's question under this topic. Okay, so this question is from 2016 GATE Life Sciences paper from biochemistry. This is question number 18. And this question states that a polypeptide with the amino acid sequence, and this is the sequence given, was dissolved in a buffer of pH 1.8. The predominant form of the polypeptide will have a net charge. Okay, so it has been asked about the charge of the on this polypeptide. So very first thing you should be knowing for this question is this is the one letter code given for the amino acid. Very first thing you should know about which letter is for which amino acid. Okay, so very let me write this sequence for you first. So this is A, G, K, P, T, H, E, K, A, H and L. Okay, so this is the one letter code. So very first is given A. So A is arginine, sorry, alanine. A is alanine. G is given for glycine. K is for lysine. And P is given for proline. D is given for aspartate. H is given for histidine. E is given for glutamate. K is again for lysine. A alanine. H again for histidine. L for leucine. L is for leucine. So out of these also you should know which are the positively charged amino acid and negatively charged amino acid. So very simple, acidic and basic amino acid you should know. So we have in the acidic we have two amino acid which are aspartate and glutamate. Okay, aspartate and glutamate, which are our acidic amino acid. In the basic amino acid we have three amino acid which are histidine, lysine and arginine. Okay, histidine, lysine and arginine. Okay, so these three are our basic amino acid. Other amino acid do not bear any charge on that or net charge on that. Okay, so if I need to see here, so if charge wise, if I'll say here 0, it doesn't have any charge. This also doesn't have any charge. This will have a positive charge, no charge, negative charge, positive charge, negative charge, positive charge, no charge, positive charge and 0, no charge. Okay, so if like that you'll see 1 2 3 4 positive charge, 2 negative charge residues. Okay, so 4 minus 2 you'll have only plus 2 left, so that is not the correct way to answer this question. Okay, so very first thing, as these amino acids are present in this form. Okay, okay, so these residues are also having charge. Okay, in a positive charge and a negative charge. So if I leave the this particular one N terminal and this particular one in C terminal. So other all in between these residues are involved in making the uh, making the peptide bond with each other. That is why this particular charge of their amino terminal and carboxy terminal of this individual amino acid is not being counted here. That is why no okay, so that is not being counted here. So for that, because they are involved in peptide bond formation, no charge will be counted. Otherwise net charge will include that this particular charge also. Okay, so now, so the question states the polypeptide with amino acid sequence this was dissolved in a buffer of pH 1.8. So it is very specifically given pH 1.8. So the predominant form of polypeptide will have a net charge of. Okay, so this question is related to pH. So very first thing, at which pH it will be in protonated or deprotonated form. So amino acids, if it is a basic amino acid, it's N terminal, it's in the R group, it will have this particular structure, which is it can be in protonated form or deprotonated form. Okay, so this is protonated form, this is the deprotonated form. Okay, deprotonated form. Okay, so if this is for basic amino acid, if I'll write about acidic amino acid, so acidic amino acid, so there in between part I have not written, that will also be there. I'm just writing a basic structure which will, so in the protonated form this will also have this, and deprotonated this will have this. Okay, so in the protonated form the basic amino acid have a positive charge, but the acidic amino acid will not have any charge because it is protonated, so it is have zero charge. In the deprotonated form the basic amino acid will have zero charge, but the acidic amino acid will now have the negative charge. Okay, so this knowledge we should also have in calculating the net charge. So that depends upon the pH. Okay, so it now it is like pKa value. So the pKa, a little information you should have about pKa as well. So at pKa the protonated and deprotonated forms are equally distributed. 50-50 percentage of both will be there present, 50% protonated, 50% deprotonated. But as the pKa will increase, the amino acid will present in the deprotonated form, and at pH above in the deprotonated form, and pH below this it will present in protonated form. Okay, so a little knowledge is we have. So generally all basic amino acid have the pK, very high pKa in the range of 6 to 12, some that much pKa it is having. Okay, so if lower than their pKa, like lower than 6 if I'll say, so they will be present in the protonated form. Even in for the acidic amino acids, if I'll say, the pKa values are very low. Okay, there the pKa values are very low, in 2 to 3 or 4, this range we have the pKa's of the acidic amino acid, but they are also lower than the pKa, they will be present in the protonated form. Okay, so the pH which is given here is very low, that is 1.8. so all the acidic amino acid or basic amino acid, the pKa, the value is far very low than their pKa value. So the these amino acid side chain will be predominantly present in their this protonated form. Okay, so this protonated form, and as well as the side chain N-terminal chain, they also have, because if the pH is very high, many protons will be present for the many protons will be present in the this particular buffer. Okay, in this buffer it will be proton rich buffer. Okay, so acidic amino acid will take up this proton and become neutral, and basic amino acid will take up the proton and become positive. And in between, all the amino and carboxy group of these amino acid are involved in peptide bond formation, so no charge will be allotted. But the free amino group and the carboxy group, so now this carboxy group will be taking up the proton and become neutral, and this particular one will take up the proton and becomes positive. Okay, so here uh, uh, so here if we'll count like this, so acidic amino acid, these two acidic amino acid will have the neutral charge on it. Okay, and all the positively charged amino acid will have their positive charge side chain, plus one charge because of the side chain. Okay, so plus one, plus one, plus one, and plus one because of their side chain. And this particular carboxy group will have zero charge, and this particular amino terminal will have also a plus one charge in it. Okay, so now we have 1, 2, 3, 4, 5 positive charge, 5 plus 1 charges all combined. This amino acid or this polypeptide chain will have a total of plus 5. So the amino